Hi, this is Pablo Spot. I'm George. Welcome to another episode of Productivity Using Containers, and today we are going to look at how I use containers with backend development. So, let's start coding. So before we start doing any actual work, just a few housekeeping items. First is, this video assumes some knowledge of Docker containers. So if you're new or you need to brush on your Docker container knowledge, please check the link on the description below. Also, we're not going to be developing any backend service on this video. I'm not going to show you how I write JavaScript or TypeScript code to build a backend service. However, I'm going to show you how I leverage on containers to become more productive while doing backend development work. So this is my story. I've been meaning to upskill myself with programming languages and development framework that I don't have much experience with. And late last year, I came across what I think is a very good material, but it's a very long YouTube tutorial on full stack React with TypeScript and GraphQL. The backend service on this tutorial requires Postgres for the database and Redis for in-memory cache. And companies normally have people who have the expertise to manage database and memory cache services required to run a system. And some companies even opt for managed services provided by external service providers. So as a backend developer, you probably don't want to spend so much time trying to install, configure, and set up database and in-memory cache services on your local machine. So this is how I did it. So we know that we need Postgres and Redis Docker images. So let's go ahead and pull those images from Docker Hub. So if I open my browser and go to Docker Hub, then on this search field, I'm going to start plugging in the name of the image that I want to pull. I search Postgres. This will return a list of Postgres related Docker images. But pay attention to this official image badge that gets attached to a particular image. This is generally an indication that this is the right and proper Docker image to use. Also, if I open this page further and then scroll down to the description, it also says who maintains the Docker image. So it says here it's maintained by Postgres Docker community, which again is generally an indication that this is the right source to use. I normally just run docker pull Postgres, which means it's going to pull the latest tag. But I usually get into the habit of checking what version of application is attached to the latest tag. So to do that, I go to tags, search for latest, then click that link that says latest, then scroll down to the image layer details. And then somewhere here, line 12 says the major version for the Postgres is 13, and then the detailed version is 13.1-1. Just some reference in case someone's interested to know what version of Postgres I have running on my local. So let's go ahead and go back to our VS Code. And then let me pull the Docker image for Postgres. So the image has been downloaded. Let's do the same thing with Redis. So if we go back to our Docker Hub and then change that to Redis, again, you have a long list of returned Docker images, but this one has the official image badge. This is what I'm going to select. So go back to my VS Code, do a Docker pull this time for Redis. So it has successfully pulled the Docker image. Now if I just quickly run Docker images, it will show me my Postgres and my Redis. So now that I have the Docker images that I need on my local machine, I need to know how to start Postgres and Redis as daemon processes so they can run continuously on the background. So let's start with Postgres. So if we open the documentation in Docker Hub, in this documentation, it mentions some environment variables that I can use to start my Postgres database here. So we've got Postgres password, user, and DB. So if I go back to my VS Code, let's adjust our terminal a little bit. Let me put that a little bit higher and then clear this. So to start my database, I need to issue docker run Postgres user and set it to Postgres environment variable Postgres password. Let's set it up to the same value, and then my Postgres _db is my db, and then I need to expose the the default Postgres port from inside the container to my local machine. So I do -p 5432 and then I need to run this application in the background. So I issue -d, and then I want to name my container based on what I want. So I just go -- name my Postgres. And then lastly, reference to the name of the Docker image. So it's Postgres. Then if I run that, it will return a long value container ID. Now if I do Docker container ls to list down running containers, so I've got my Postgres database running in the background. Redis is easier to set up. To start running Redis, I only need to run docker run -p to expose the port for Redis 6379, and then -d to run this in the background, -- name for the custom name, I call it my Redis, and then lastly reference to the Docker image. So again, it returns a long value for the container ID, and now if I run docker container ls once again, it will show me both my Postgres and my Redis containers. If you have Telnet installed on your machine, you can verify connectivity to both Postgres and Redis running locally. So let's clear this out. And then all we have to do is we run telnet localhost and then the port of the Postgres database 5432. And then it says connected to localhost. So we can connect to the Postgres database successfully. And then we do the same thing for Redis, which is running on 6379. And then it also says connected to localhost. So that's an indication that we can connect to both Postgres and Redis locally. So to save myself from the intricacies of starting Postgres and Redis containers, I use Docker Compose. So if you need to learn more about Docker Compose, I'll put a link on the description below. Let me show you the Docker Compose that I've prepared for this tutorial. If I quickly adjust this, put it down a little bit. So this is my Docker Compose YAML file with the most basic setup. So lines 3 and 11 are the custom strings used in container names. And everything else maps to the parameters that we use in Docker commands like ports and image and environment variables. So let's clear this. And to start my containers, I need to be in the same location as my Docker Compose config file. So I need to be inside Reddit server, and then my Docker Compose file should be in here. Yep. So before I start running the containers using Docker Compose, I need to stop and remove the containers that I started using the normal Docker commands. So let's have a look at the Docker containers again. And then what we need to do is we need to run docker stop on the Redis and Postgres containers. And then I run docker rm my Redis and then my Postgres. So now that all the containers are gone, let's start our Postgres and Redis containers using Docker Compose. So I run docker compose up and then pass a -d switch to run the command in the background. If I need to look at the logs, I issue docker compose logs, and then it will show me all the logs. Let's clear that out. Now, if I want to see the running containers, I run docker compose ps, and then I've got my Postgres and Redis on an up state. So both my Redis and Postgres are running in the background. So suppose I need to start from a clean slate for both my Postgres and Redis. All I need to do is to stop and destroy my current containers. So to do that, first I need to stop my containers, and then I need to issue docker compose rm to destroy the containers. And then I say yes. Then if I run docker compose ps, there's no containers running. So with all the current containers gone, I can start a new set of containers by running docker compose up -d once again. Docker compose up -d. So this is very useful if you've messed up your data and you want to use a fresh Postgres database and Redis in memory cache. So let's start integrating this with my backend service. So this is the code that I have written while following through the tutorial that I mentioned earlier. I'll put a link on the tutorial in the description below if you want to go through it, but be mindful that this takes more than 10 hours. Again, this is written in TypeScript, running on Node.js as its runtime environment, and it uses GraphQL for data-related API calls. So before we start the backend application, let's first stop our database and Redis containers. So let's clear this out and then issue docker compose stop. And then let's start our application by running npm run dev. This should fail because we don't have Postgres and Redis running in the background, which shows on the console log. It says connection refused, and it's trying to connect to the database. So let's exit that, clear that out. And then now we start our Postgres database and Redis in-memory cache. So docker compose start. So now that's up. Let's start our application again, npm run dev. And then that should start the application. So notice at the end that it says server started on port 4000. So this is an indication that the application started fine. Our backend service is running. Another way of verifying if our application is running fine is to access it via browser. So let's open our browser and then connect to our GraphQL playground, which is normally in localhost 4000 GraphQL. So it's actually loaded successfully. So let's try to register a new user, call it ABCDEF, change the email ABCDEF, and then run that. And then you see that it has successfully inserted or registered the user. So now if we log in using that user, using the login mutation, our user is ABCDEF. So let's change that and then run that. And then it shows that the data actually exists in the database. So let's say we want to start from a fresh database and Redis cache. So let's go back to our VS Code and then let's stop our application and then clear that out. So our application is no longer running. And to verify that, let's go back to our browser and load the page once again. Yeah, the site can't be reached. So let's go back to our VS Code. And remember, to start a new and empty database and Redis cache, we run docker compose stop. That's to stop the containers. And then we run docker compose rm to destroy the containers. So we say yes on that prompt. And then our old Postgres and Redis containers are gone. So to start a new and empty Postgres database and Redis, we just issue docker compose up -d, and then this should be a new set of Postgres and Redis cache. So now we start our application. Let's clear this out and then start our application. And then again, it says server started on port 4000. So that's a successful start of the application. Let's go back to our browser and then load that again. So I still have my login mutation on my GraphQL playground in here for the user that we inserted earlier. But because we wiped the data out and then we started a new empty Postgres database, if I run this login mutation, this should fail because this no longer exists. Yeah, so you see it says user null. So that's how I use containers to develop my backend services. Bottom line is, containers help me achieve productivity by number one, not having to deal with installation and set up procedures for services that I need to verify that my backend service is working properly. And then number two, I only have to spend a small amount of time for components that ultimately I don't have to worry about. Once I have identified the containers that I need, they are almost out of the box to set up, and then I can start spending more time and focus on writing code for my backend service. And then number three, because these containers can be ephemeral, being able to destroy these containers can be very handy when I want to start from a fresh and empty database and in-memory cache service. So there you have it. As usual, send me some likes if you find the video useful. And let me know what you think on the comments below. And remember, you learn more by doing. Until next time, bye-bye.